My name is John Leach. I'm the Chief Technology Officer at Splice Machine. We're a relational database company. We've been around for about 4.5 years now. And our goal really here is to power hybrid applications. This talk, I'm going to just tell you real quick what Splice is, and then I'm going to kind of go really in deep on us building out our cloud service architecture, and then showing you how we use DCOS and Mesosphere to launch HDFS, HBase, Spark, Zeppelin, Kafka. I mean, we've got the whole thing in there. So I'll go deep into that. And if you have questions, please interrupt and just raise your hand or yell at me. All right, so I can do that. Cool. So always a question I hear is, what is Splice Machine? So our goal is to be able to power OLTP and OLAP applications. So it's SQL based. We want to be able to do quick reads and writes. At the same time, we want to be able to do large joins and aggregation queries. We do that. We split it into a dual engine architecture where we use Spark for analytics and we use HBase for real time. And we share the HBase file system. We wrote some custom code so that we can access H files in Spark, and HBase can use the H files that they want to use for real time. So that's one of the things that we've done. We use ANSI SQL. And as far as where we're really wanting to go, we want to go more into app services. So we want to be able to not just talk about HDFS and HBase and running SQL. We want to actually get to applications and running applications, whether they're machine learning applications or streaming applications. And I'll show you some examples, and I think it'll help think about where we're going. And then lastly, and what I'm talking about today is the Elastic Cloud. So Splice Machine, as we're building out our Elastic Cloud on top of our first release will be on AWS using DCOS and Mesosphere. So first, when you want to build out a service, the question is, well, what were the challenges we tried to do when we built out our service? And the first thing, gosh, this is really terrible. It's awful. So what we wanted to be able to do is to have a single page where someone can say, okay, I want to build out an HBase cluster. I want so many terabytes. I want so many CPUs of compute, and of analytic compute, and so many CPUs of transactional compute. And I also want to put so much storage on S3 versus just an HDFS. And we want it on a single page. And you can drag the slider. Does that make sense? So you want somebody to be able to say, hey, I want to procure this. And just drag the slider to varying size to blow out your cluster. Once created, our goal was to be able to be elastic and have monitoring capabilities. So we wanted them to be able to see CPU, disk usage. But more importantly, if you have a cluster that's 10 terabytes and 5 nodes, you should be able to just drag the slider, and all of a sudden, that should be able to resize inside your either on-premise or cloud deployment. On top of that, we said that we wanted to be able to support a whole host of features above and beyond what a database generally does. So most cloud databases, you get a port, it uses JDBC, ODBC, and that's kind of what you have. We thought it would be really neat to bundle Zeppelin and kind of show all the capabilities of Splice and HBase automatically kind of ready to go. First thing we wanted to be able to do is, just be able to start basically SQL queries inside Zeppelin. So you can store your SQL queries, you can schedule them, you can run them. Second, we wanted to be able to support PL SQL. So we have a PL SQL interpreter we spent a lot of time building that can execute PL SQL. We wanted that to be able to run in Zeppelin as well. Third, we wanted to have streaming integration. So we wanted to be able to support Kafka and Kinesis using Spark streaming. So from this application, based on the analytic CPU you asked for, you should be able to very quickly blow out and run the Spark streaming operation. I'm setting this up when you're thinking about all the components that are required to be able to execute this. It's considerable. So these were our requirements. Likewise, they wanted to be able to support Spark SQL. So it wasn't enough that you could run Splice Machine SQL. The requirement was we want to be able to run Spark SQL on top of Splice Machine tables. So we wanted people to start understanding that it's an open system, that they can use any of the tools that they're comfortable using. Another requirement, we want to be able to support R. So if anybody wants, because we're really wanting to be able to build AI applications, really hard to build AI applications if you can't run Spark and R and basic statistical modeling. So we bundled R into this offering as well as a requirement. And lastly, We need to be able to support real applications like Unica and off-the-shelf applications as people move to the cloud. You have to be able to run like real applications and also artificial intelligence applications. So applications that have a real-time component that are coupled with Spark, building models, applying those models in real time. So that's really our focus. Okay, so I, at that point, thought it's time to resign because there's no way I can do this. I thought about, well, and then I started saying, well, what is it that we need to do, right? We need to build a service, and basically we need to be able to deploy it on-premise and in the cloud. And I didn't want to build different frameworks for each. Like I don't want to have a framework for AWS. I don't want to have a framework for Google Compute Engine. I don't want to have an on-premise framework. I thought that would just be too much to test and actually do. Second, how can we isolate resources while efficiently using resources? So one of our big challenges with customers, you blow out this huge Hadoop cluster, right? And then their system admins are like yelling at you going, you used 5% of the CPU during this window. Boy, it'd be nice if we could have used that. These nodes are sitting completely idle. Well, these nodes are really hot. Why can't we add an extra HBase node easily to an existing HBase node? So you start getting peppered with all these questions. And we wanted to address that for our on-premise customers. Third, and this is what I'll talk a little bit more about because I think it's a reality that maybe our community is not coming around to. How can we take advantage of different external storage capabilities on a per container basis? So really use containers, but also recognize that this idea of JBODs, that's not really transitioning to where things are now. Most companies are saying, hey, I want to go to one of the 3 major cloud providers, or I want to run OpenStack or something internally. And they have external storage solutions. And how do we interplay with that? How do we make that work? How can we use external storage to decrease the overall cost? Initially, HBase was, well, we throw it in HDFS, right? Well, that's no longer a reality in the cloud. HDFS is relatively expensive compared to maybe like an S3 or some sort of blob storage. So you have to have a tiered storage strategy. Where are you putting backups? Where are you putting import files? They need to be in the cheapest place possible. And hopefully that makes sense, where you're really just looking at how much does it cost per gig to store this data. How can we, and this was one that's really, this is the hardest part, I thought, how can we elastically scale instances of Splice machine and the underlying infrastructure in a multi-tenant environment? So when I'm talking multi-tenancy, I'm not saying, oh, I'm going to put a 50-node HBase cluster and have some people bang on it and pray that their queries don't break this thing, right? Or that they're not putting enough load on it to cause stress. I'm actually talking about a complete multi-tenant environment where you can build out your own Spark implementation, HDFS, HBase, where you can have that whole implementation isolated by yourself in containers. The thing that scared the heck out of me is I showed you all that cool Zeppelin stuff. So I'm basically allowing someone to write any code they want in that Zeppelin notebook, right? And they're behind the firewall. So if you have 2 customers, all of a sudden, holy smokes, I've got somebody who can write code, and I've got a bunch of containers floating around. How do I convince somebody that this is not just like, for Kaz to come and take everybody's data at that point? So how does this work, right? So that was a huge issue for me as we tried to do Zeppelin. And then how do we monitor what resources are used by whom and when? So ultimately, we have to build somebody for this or understand the cost, or departments have to understand how much that instance of HBase cost. How do you do that? These questions make sense. Like, this is really about, and then on top of this, we had our reality of our current customers. Our reality of our current customers is it's really hard to deploy applications on HBase. And why is that? Our customers don't throw things directly into production. So they want to be able to spin up a dev cluster, test it, bring it down. They want to be able to spin up QA clusters, test it, bring it down. They want to be able to spin it up for load testing, bring it down. And then they want to be able to deploy in prod. And they want a clear framework for how to do that. And HBase is not some monotonic thing that's sitting off on the sideline that people use. HBase is part of an application stack. So if you're building an artificial intelligence application or supply chain management application, and you know it's going to create a tremendous amount of data, you want to be able to use HBase, you want to be able to use Spark, HDFS, all these tools, Kafka. But you need to have that go with your application. It's no longer some standalone thing that you shared service. That model does not work. What people want to be able to do is just deploy it. So these were some of the challenges. And then, like, I was even laughing. This morning, I had 4 Slack messages related to customers who are having problems with configuration. Kerberos, somebody misplaced some file. Somebody ran something, but they don't remember what it was. All of these things that when we think about it, it's because we're using mutable infrastructure. If we were using immutable infrastructure like we are, who cares? Kill the node and restart it. It'll build out the appropriate configuration and all the things that your application expects. So it's a very different model, and one that we had to kind of move towards. Our landscape is no longer, like, I just want to make sure you press upon this. When I walked in, I used to be like, okay, buy some servers, JBOD, blah, blah, blah. 6 months later, they install it, you get the Hadoop running. That's not the world anymore. People want to be able to do a POC in a couple weeks. They've picked one of these cloud platforms, or they're using some sort of Isilon product, or they're using OpenStack, and they want you to be able to go into their infrastructure, spin up quick, and be able to execute your POC and run your applications. It's no longer the world where, you know, we're just telling people what to do. That's just not the, people have kind of picked their strategy. So what we picked was a product called DCOS. And the big thing about DCOS is it basically gives you a capability of deploying your application. And the most important part about DCOS is that it gives you, well, and I'll kind of go in this a little more detail here. So DCOS in itself is an amalgamation of products. How many people have heard of Mesos? Cool. How many people have heard of Marathon? Cool. So Mesos is basically a distributed Linux kernel kind of strategy for an operating system. And Marathon is a way to actually execute those pieces. DCOS is a little different because it's going on a totally different strategy. So how many people have used containers? Container 1.0 or Container 2.0? Yeah, what is that? So Container 1.0, which is what we lived through the last 5-10 years ago, was everything stateless, right? You spin up containers, great for web developers who want to, you know, hack something up and run it, right? Well, now there's Container 2.0. Container 2.0 is both stateless and stateful. And it's really about orchestrating the entire deployment of a service, of what you're wanting to do. So it's no longer that containers are just used for things that are stateless. It's really about that stateful piece. And that's why things are changing, I think, so rapidly. And that's why you hear popularity of DCOS, Kubernetes, those types of products. And then this, got my slide terrible, but up here is actually the DCOS product. So Mesos is used to map the tasks to the physical operating system. Marathon is actually the app that you're running, and then DCOS is behind it, which is, and I'll kind of show you the details of how you do that. The second thing that's really powerful is it's a second level scheduler. And what does that mean? So Yarn, I can take things in Yarn and have capacity, and I could throw a task out there, and Yarn will say, yeah, I can do that here based on the amount of memory and CPUs. A second level scheduler is a little different, where the application you submit to make this thing work is actually a scheduler in itself. And it will tell you, hey, I want to do these 10 things in order. Some things can be blown out in parallel. Some things have to be serially executed. This has to happen before another thing. These two processes can't be placed on the same nodes, physical agent nodes. It goes through all kinds of placement rules. It also allows you to have different rules for when you think something is up and going. So it builds a whole infrastructure around it. And I'll show you some detailed configuration of that. I think it'll maybe drive it home. So DCOS by itself, like I said, so at the highest level, you're basically doing Mesos, Marathon, and this DCOS product. Underneath there's a whole host of products that they're actually using at the low levels. So they're using Mesos DNS. So when you launch a container, it knows what the IP address of that container is. So there's a whole networking infrastructure. And obviously doing this in 30 minutes is a little aggressive. But the thing I want you to kind of get out of this is it is a amalgamation of different products. And that's at even a higher level. And when you go lower, there's Spartan. There's other products even underneath that that are actually providing things like networking, replication, all these types of concepts. And the coolest part is they came out with this DCOS Commons, which is a software development kit. And what this allows you to do is basically in YAML kind of describe what you want it to do, coupled with some Java if you want to do advanced constraints or placement rules. And based on all of this, you can actually create containers and build these out in your environment. I'll show you some examples. This is an example of the YAML file. And sorry, it's probably a little harder to read, but what it is you basically say the framework. So from our case, that web UI, whoever your name of the cluster you want to build, that's your framework. And it throws it out there. And then it comes up with what the concept are called pods. So in our case, there's a whole host of pods, and I'll show you those deploying. But first pod in most of these is Zookeeper. What is your cluster identification mechanism? And what this allows you to do is say, how many CPU do I want Zookeeper to have? How much memory do I want Zookeeper to have? Where do I want to grab the Zookeeper information? In this case, what network, and I'll get into the networking piece. What network do I want the Zookeeper to come up on? And then what are the things that I want it to run? I want to have it do a resolution, and I want to start Zookeeper in the foreground. How much CPU and memory, and what ports do I want to open? And then once you have that, you have all these pods. Now let's think about what we want to do. We want to deploy a complete HA Hadoop implementation, a complete HA HBase implementation. We want to deploy Zeppelin. We want to deploy a Kafka set of a cluster of in nodes. And we also want to start our PL SQL interpreter. So we've got a lot of things that we want to do. So based on what I showed you before, where you describe in the YAML what you want it to do, you can easily come in here and say, here's my plan for deployment. I'm going to deploy Zookeeper in parallel. I'm going to deploy the journal node in parallel. I'm going to deploy the name node serially. I'm starting 2 name nodes in HA. I'm going to deploy the data nodes in parallel. I'm going to deploy the HMaster serially. I'm going to deploy the H region in parallel, Kafka, PL SQL, and then Zeppelin kind of went off the screen there for me. You're actually standing up your entire infrastructure. So no longer do I go to the sysadmin and say, I need this port open, or I need this networking configuration, or yeah, I need you to install 10 nodes of HBase. That day's over. What you go is you say, look, we have 100 nodes of DCOS that's running with this much memory and CPU. I have this application that I want to roll out. And all you're really configuring is your CPU, memory, and your numbers. All the configuration is dynamic, and you're blowing this out as a complete application. And what's really cool, and I don't know if I have an example here, is they also have health checks. So on each one of those, you can define health checks. And these aren't like lame, like the thing goes red health checks. These are, if you run it 5 times and this doesn't happen, you kill the container and restart. So this is really about trying to get out of the business of kind of watching a Hadoop and HBase cluster. This is really about it self-healing if it has issues and problems. So there's a whole host of capabilities there. So what does this look like when we want to stand up? So I created an HBaseCon West cluster. It was like a 4-node cluster. So what does it do? First thing it does is start the second level scheduler. The second level scheduler uses that YAML file to figure out what it wants to deploy and in what order. And then it starts standing up. Stands up Zookeeper. Those are staging. So it's blowing out, I mean, it's literally pushing all of the things that it needs to run Zookeeper in parallel onto those containers. Next, standing up the journal nodes in parallel, standing this architecture up with health checks. So if something's sideways, these will go red. If there's something wrong with the infrastructure, it'll restart. It's formatting name nodes. Standing up the name node. Standing up the journal nodes, the data nodes. The HMaster, I think you get the sense. It's building out an entire HA environment for HBase, wrapped to your application. Now, the models I've heard so far today are different. The model is, I have a 50-node Hadoop cluster, and I've got some stuff on it, and kind of everything plays in that environment. And we try to keep it available by limiting things. This is a very different model. This is a model where you have 50 nodes, you have so much memory and CPU, they're all in containers, they're all isolated from one another, and they're running in those environments. This is what you would call container 2.0, because we're no longer just seeing, these aren't just stateless entities. These are actually stateful applications. And then you deploy kill SQL Zeppelin. So this is like 24 different processes that are deployed when you're doing this. And with health checks on each one. So in Splice Machine, if a region server can't serve a query, it goes red immediately. You have alerting to pager duty. Next thing you know, if it does that 4 or 5 times in a row, there's something sideways. Restart the region server. Okay? This is probably the coolest technology I've worked with this year. It's a product called RexRay. Actually, RexRay and Calico are the two cool ones. Okay, RexRay. Storage management basically for container runtimes. So when we think about storage, we think of, okay, we're going to build out this huge Hadoop storage infrastructure. There's another way to think about storage, right? The application developer can say, I need 200 gigs. I need this volume to be able to run this application. So what does that mean? DCOS uses this product, RexRay, where you can literally go in, and in this case, for this container Zookeeper, I'm creating a SSD volume using an EBS from Amazon. I didn't have to mount it to my instance. I didn't have to futz around. Didn't have to call a system administrator. Didn't have to do any monkeying around. I literally, the application said, hey, I need these volumes. And it goes out and mounts those as it starts. And it dynamically goes and gets that. So it'll actually, when you go out to Amazon, you will actually see your volumes being created on demand. So this model of, I have this huge Hadoop cluster and I throw stuff against it, this is very application specific. I want a 20 terabyte cluster to run this IoT application, this machine learning application. And then you describe it as an application developer, and then that builds out that entire infrastructure. This is probably the hardest part of our implementation right here. So right now, generally, at our customers are on-premise. It's a yard sale, basically. Hadoop is this one big IP address thing, and we basically use Kerberos to kind of think that we're secure, but we have really no network isolation between anybody working inside those environments. And I showed you Zeppelin, so I basically that's like a hacker's paradise, right? I literally let you compile code, load code. You can load your own code from Maven. I mean, you can hack us real easy, right? What we did to change that is to say, okay, we're going to use Calico. And what Calico is container networking. So inside DCOS, when it goes and asks for an IP address, it'll go, instead of just giving you a random IP address, it'll go to Calico and say, hey, this is John's cluster. And the group will be John's cluster. I'll get a private IP address that's identified with John's cluster. John's cluster cannot see Michael Stack's cluster. There's no root to it. They have actual security policies for ingress and egress. And it's very simple. It's just literally, and these slides are a little shaky, but you just literally put the network name in there. And that's automatically passed on. So think about this. As somebody who wants to build a real world application, You can deploy all your infrastructure. You can determine what storage is best for your infrastructure. You know, you may have something you don't really care about, so you're going to run it on spinning disks, and it's going to be cheap. Or this may be a high-performance application you want to run on SSDs. The application developer and the deployment can choose that. Secondly, you're creating networks on the fly. So no longer this attitude that, well, everybody can kind of see everybody's stuff, and yeah, we've got some security, but it's kind of all out there, and we use kind of file system security. That doesn't work when you're building applications. Application level security is much more sophisticated than just like file system rules and file system username permissions. So this allows you to literally be on different networks for your implementation. That one's terrible, but what it was showing is how crazy the topologies are of networking. So what we see is that when you look at all the different connections inside of a Hadoop cluster, you realize the need you need for secure networking and having your own network. Where I spent a decent amount of work is on Spark, allowing Spark to support container networking. So when Mesos is used as the scheduler for Spark, as it creates its executors, I wanted to make sure those executors were also in the private network. So we built that into Spark so that when you launch Spark, it actually Spark knows, hey, I should use this network for complete isolation. Just quickly talking back to what Splice Machine is. It's obviously, or not obviously, it's a SQL relational database supporting subqueries, triggers, transactions, a whole gamut of SQL capabilities. And with that, that's all I had. And I know that's a lot to try to slam Mesos and all this stuff into such a short time window, but I appreciate that. Any questions? Yes?
So what led you down the road to pick a DCOS versus?
Spark did. So just Mesosphere made a lot more sense with Spark. We have Spark embedded as like basically any SQL statement you can run in HBase, you can run in Spark in our system. So we were already committed there like 3 years in. So it wasn't, for us, it just made sense. I think they're both, to be honest, after looking at it, very similar products. They're that container 2.0 product. They're forcing us to start re-envisioning what a container is and how that works together. Yeah. Complete rewrite of that. Yeah, because we.
Repeat the question.
Yeah. Oh, yeah. So inside DCOS Commons, there was already kind of. So some of the stuff there is pretty, I'd call alpha, in the sense of people have kind of started developing and they have kind of an HDFS framework. There's nothing for HBase yet. They kind of hacked it together. We didn't really use that. We used some thoughts from it, but it was pretty raw. And we had a kind of a bigger strategy. We wanted to make sure we had, external storage if appropriate, and we wanted to be able to use private networking. So we're really focused on our kind of attack. Yeah, that's a good question. Any other questions? Cool. Thanks a lot.